Okay, so let's build a 2 degree of freedom system like we did today in class. And let's actually make it work for the problem that was in the vibrations book that I've posted online. So let's start by opening a new model. And we'll save this as DOF system. Okay. Go ahead and save that. Oh, it doesn't like the 2. Okay. Let's start out. Let's get our integrators in there for our first system. So 1, 2. Keep these close together because I don't have a whole lot of room to work with. And let's go ahead and get some math operators here. Let's get a gains. And we're going to need to flip this. And we're actually going to need 4 of these. Okay. So there's 1 and 2. So there's gain. We'll make these the extra ones. Here we go. Okay, so let's make this our damping coefficients. Coming back, let's go ahead and label those. Connect that up. And then the other one we'll make is K1. K1 plus K2. If you look at the equation, you can see what I'm doing here and relate this back to the equation. So that takes care of that. Okay. And we're actually gonna, this is going to be feedback that's going to go back to the other spring mass system. This is going to be some information that comes back. So we'll go ahead and connect that up. And this will be the K2 that goes to the other system as well. Okay, so we're going to need a one more gain in here for /M1. Okay, we'll go ahead and connect that up, and we're going to need a summing block. Okay, and this summing block is going to have 3 inputs that are positive and 2 negatives. Okay, and let's go ahead and get that set up. We'll go ahead and connect these in. There we go. So that's connected up. Okay, we'll put a source. We'll go ahead and put a. We may use it later. We'll put a source here. Step. Let's go ahead and make the step time start at 0. But we'll also put that the value is 0 because we're going to actually do this with a displacement, initial displacement. Okay, so let's go ahead and make our second system, which will be similar to our first. And that we'll start it out with the integrators. Let's line them up. That's right there. Okay. I'm going to connect that up. And we will also need math operators again. And let's flip that around. Oops, let me pull this. You can't quite see it, but I'm flipping this. I'm flipping the block the other way, and then I'm going to make a copy of that. And this will be our C2. Okay. Going to connect him up. This will be K2. We'll connect him up. Okay. And we'll need a gain going the other way, which will be 1/M2. Go ahead and connect him up. And we will need a summing block similar to this one. But in this case, we'll go with 2 pluses and 2 minuses. Okay, so we've got those connected up. We can go ahead and connect these up. We did before. Okay. Let's pull that down a little bit, make it neater. Okay, and here we have this. These guys can come in here and hook into here. But we also need to pull off of these guys back to here, so let's go ahead and do that. Let's neaten that up a little bit. And we'll make this one come down here and pull off of him. Okay. I don't know why it does that. There we go. Okay. So we need to put in our initial condition, which in our case is 1. All the other initial conditions were 0. I can see I'm already up to 7 minutes. I've got to put in my constants. C1 equals 0. C2 equals 0. K1 equals 24. K2 equals 3. Is that right? Yes. M1 equals 9. M2 equals 1. That looks correct. Okay, so I've got all my constants in here. And now I'm going to need a scope to look at this. Okay, so I'll get sources. I'll just grab a, sinks I mean. I'll grab a standard scope and stick it over here. And I'll need to route 2 signals into it. Or actually, I could just, let's do this. We'll make this, show you the scope parameters. I brought up here. I did that by, I'm going to use 2 axis. Okay? So if I change that to 2 axis when I bring up my scope, and I did that by clicking on this little gear right here. Okay, I double click that gear and you see it brings up a little thing that allows me to change some of the attributes. So we'll get into that more later. I just want to get this. Here I have my 2, my X and Y, or my 2 displacements, I'm sorry. My DX1 and DX2 for my spring mass system. Okay. And I think we're ready to run. Let's go ahead and run it. Okay, that looks pretty good, but I noticed that in the actual results that they ran at 20 seconds. So let's run it for 20 seconds. And if we do that and we compare that to the example in the book, we see very quickly that we have gotten the same answer. Okay, and that looks really good. Stretch that out a little bit. Okay. And you can change the scale on these and everything else, but that's good enough for now. That gets us started, and we know that we have a system that's accurate, and we can build from here. The next video, we'll build this into subsystems and do a little bit more with it. Hope you enjoyed this.